All right, so I'm very excited to be here for many reasons. Not only to share with you guys some of the findings from the AI Index, which in my completely unbiased opinion is the best report in the world on trends in AI, but I guess you guys can judge that. But I'm also from Toronto originally, so it's always a pleasure and a thrill to be able to come back and speak to a Canadian audience. So let's just get into it. What is the AI Index? So the AI Index is a project that is at Stanford University, and it's a project that aims to track, distill, visualize, and collate information on trends in AI across a variety of different domains. So the index is a big report. It's released every year around March, and we tell a story of what is going on in AI from technical trends, so like what is AI capable of doing. We tell a story of what AI can do from a policy perspective, how concerned are policymakers with AI. We tell a story about what is going on with AI from a diversity perspective. How good are we with diversity issues in the field of AI? So it's a report that really looks at AI from a very wide-ranging perspective and considers a lot of different issues and a lot of different perspectives. And it's a report that I think is intended for a less technical audience. It doesn't necessarily mean that you won't learn something if you are a bit more technical in nature, but our report is pretty widely read by senior policymakers in the US, in the European Union, in the United Kingdom and Canada, by major industry leaders that want to get a sense of what AI is and what's actually going on. And I think our report does a very nice job of telling that story. And today I'll be telling you guys about the 2022 report. It's also important to know a little bit about the team that puts together the report and makes it actually possible. So at the moment, I'm the research manager responsible for the report on a day-to-day level, but we're co-chaired by Jack Clark, who is the co-founder of Anthropic, and Ray Perot, who's a senior research scientist at SRI. But we have a lot of other distinguished thought leaders in the AI space that supervise the report and give us insights. People like Eric Brynjolfsson, who's a leader in the economics of AI field. People like James Manikia, who's very important at Google in terms of developing new AI ethical frameworks. So there's a pretty robust team that works to put the report together. It's also very important to mention that the report would not be possible without the wide range of data providers that work with us. So people like CSET, LinkedIn, McKinsey, Bloomberg, they all give data to the report that we then use and then we kind of share. And that's really, in a lot of ways, what makes the report possible. We also collect some of our own data and do some of our own novel analyses, but generally speaking, these vendors make it possible to do the things that we ultimately do. So with that, let's actually get into this presentation. I'll kind of say from the beginning what I'm actually hoping to do in this presentation, and that's basically tell a story of what is going on in AI as told by the 2022 AI Index report. So we'll be looking at a lot of different things, a lot of different topics, and I think the focus is going to be a bit more industry-oriented, as in there's a lot of trends in this report that we can unpack. I'm going to be talking about the ones and kind of discussing how they relate to trends in industry. You know, if you are a person that is thinking about working with AI in business, what is actually going on in the AI space, and how should you be reacting to those things that are going on? We'll be talking perhaps about some technical terms, and if there's anything that I say that is confusing or that you don't necessarily know, or you're like, what the heck is ANLI or something along those lines, just shoot your hand up. I'm more than happy to take questions throughout this presentation. So hopefully this is going to be a good learning experience for you guys. The first thing that we're going to talk about is trends in technical performance. So we have a pretty thorough chapter that is looking at how good is AI presently and what it can actually do at the moment. It's important to note as well that we released the report in March of 2022. I will be talking about trends that are in this report. Obviously, it seems like every week there's a new breakthrough in the field of artificial intelligence, so we don't necessarily comment on things that have happened after March of this year, but we do have another report coming up in a couple of months that will touch on some of those themes. So what can AI actually do? One of the big things that we find is that AI training is getting more efficient. So this chart comes to us from MLPerf. MLPerf is basically like an AI hardware race in which a bunch of AI developers are challenged to use an AI with the same architecture and basically challenged to see how quickly they can train their AI systems to work on a bunch of different tasks. So all else being equal, the better your hardware, the faster you're going to be able to train systems to actually do these things. You'll basically notice that across the board, whether it is object detection, image classification, training times are getting much more efficient. For example, in 2018, it took 5 minutes to train a state-of-the-art classifier on ImageNet. By 2021, that had dropped all the way down to 13 seconds. We're also finding that AI systems, and I'll kind of put a caveat on this, are getting cheaper to build. This is also data from the MLPerf competition, and it looks at how expensive it is to train a system to 93% accuracy on ImageNet, a 93% classification accuracy. You'll notice that the cost is pretty high in 2017, around $1,000. This drops all the way down to $5 in 2021. That's what we find in the AI index. Why does this matter and why should you care? Well, the fact that it is becoming increasingly easier to train AI systems, as in we're getting faster, and the fact as well that it is becoming a lot less expensive might mean that you might kind of move into a point in the future where AI systems might be much more adopted by business entities, by especially perhaps medium and small-sized businesses that traditionally maybe have been unwilling or perhaps scared by the cost and the prohibitiveness of adopting some AI technologies. It is important to make a caveat, though, because some AI systems are getting very expensive to build, and by those kinds of systems, I mean large language models. So obviously, you have companies like Google, Apple, Meta that are investing millions, if not soon to be billions of dollars to train these systems. The cost of training those systems has gone up, but the cost of kind of training systems that are perhaps more narrow in their task focus appear to be going down, at least according to the AI index. We also find that the frontier is getting hungry. The frontier refers to state-of-the-art top-end research that is being done in the AI space. One of the things that we find in the AI index is that we looked at a lot of different benchmarks. So benchmarks are kind of these challenges where researchers are trying to measure up their AI systems against certain benchmarks. We looked at a wide series of benchmarks in this year's report, and of 10 benchmarks we considered where researchers trained systems both with and without extra training data, 9 of the state-of-the-art results were achieved on systems that used extra training data. So basically, if you want to do better on these benchmarks, all else being equal, you need more data. Why does this matter? Why should we care? Well, it's worth asking ourselves who has access to the most data. Nowadays, it is probably industry actors. So companies like Meta, companies like Apple, companies like Amazon, they mine massive amounts of data, and they have access to much more data than, let's say, academic institutions that might have different incentives in terms of the kinds of research they might be interested in doing. So we might be kind of moving into a world in which industry actors perhaps are better positioned from a certain perspective to leverage and take advantage of trends that are going on in data. We also find increasingly that computers or computational infrastructure is also increasingly important to frontier work in AI. So what is this graph showing? And I guess that's kind of my job in today's presentation, explaining what all these perhaps not necessarily convoluted but complex graphs are showing. This is also from the MLPerf competition. So MLPerf is, again, this kind of AI race. How quickly can you train your AI system using an underlying architecture? What you really want to pay attention to is the teal line, so the green line and the pink line here. The teal line represents the average accelerators used by top systems. So if you won MLPerf, if you had the fastest system, how many accelerators did you use? The pink line represents the average number of accelerators used by all entrants. You'll notice that there's a massive gap that opens up in 2018, and it kind of stays at that level. This is basically suggesting to us that in order to win this ML race, in order to basically have the fastest performing systems, you need, all else being equal, better hardware. And again, it's worth asking ourselves who has access to better hardware these days. Probably, all things being equal, massive corporations, especially when it comes to things like building large language models. Those are things that require massive computational infrastructure, and there are certain actors that are better positioned than others to actually have those kinds of things. Now, I think invariably, whenever I tell people that I work in the field of AI, people kind of ask me, look, how good is AI getting? Or perhaps there are some more dystopian people that ask me, like, when is AI going to kill us? I won't comment on that per se, but I can answer and I can tell you based on the index how good it is getting at certain NLP tasks, so natural language processing tasks. For instance, the ability to kind of read text and comprehend what is being said in the text. According to a variety of benchmarks like Squad 1.1 and Squad 2.0, which are very popular benchmarks for researchers in the reading comprehension and natural language space, you'll notice that AI systems have quickly kind of overtaken human baselines. So AI systems are pretty good at reading comprehension and probably better than most humans on those kinds of tasks, at least for simple kinds of reading comprehension. But AI has not mastered more complex language tasks yet. So let's take a look at ANLI. I'm sure everybody in the room knows what that is. ANLI is a test where basically researchers are being asked to judge how well AI systems can make these so-called inferences. So imagine that you're coming home from a dinner, you return to your parked car, and you notice that the window has been broken in and the laptop is missing. Most humans, within a couple of seconds of seeing this, can make a deduction that someone has broken into their car and stolen a laptop. These kinds of situational deductions are actually very important in how humans engage, and it's something that this benchmark is trying to measure. And you'll notice that AI systems are still kind of lagging behind humans. There was a massive gap in 2019, but they do appear to be getting a lot better, at least as of 2021. So we're in a position where some of these more challenging linguistic tasks are still difficult for AI systems, but they appear to be getting better every single year. Now, it's worth noting as well that we talk in the report on so many other technical performance metrics, whether it is medical imaging segmentation, reinforcement learning recommendation. If there is a technical category, it is in the report, so I would encourage you guys to read the report in its entirety. Of course, in today's presentation, I'm only covering some of the main themes and main points. Let's talk a little bit about technical AI ethics. So where's the kind of ethical space in AI? Now, before I kind of dive into some of the critical findings here, it is important to note why there's been a much more massive increase in interest in AI ethics. And I think a lot of these ethical problems stem from the fact that AI systems are a lot more capable. So you can kind of see this in facial generation. We haven't solved facial generation, but you'll notice that in 2014, 2015, the images that these kind of facial generating systems were generating were pretty bad. I think most humans would say, this doesn't really kind of look like a passable human being. Fast forward to 2021, and the images they're generating are hyper realistic. And this is true of a lot of other kind of areas of AI, and I think one takeaway that I would want you guys to have from the talk is kind of AI is here. 10 years ago, AI, I still think in a lot of domains was something that existed in the lab, something that people were playing around with. But we're kind of at a place now where AI can do a lot of things well, and because it can do a lot of things well, more and more people are going to become increasingly interested in actually using AI as part of their daily lives, which means that we're going to run into these ethical challenges a lot more. Now, if you really want to trip perhaps down dystopian lane, you can go to a website called whichfacesreal.com, and it's a very simple interface. It pops up two faces, one of which is generated by a human, the other which is generated by an AI system, and you're kind of tasked to guess which one is which. So let's maybe kind of take a quick poll of the room here. Who thinks that the face on the left is AI generated? Who thinks the face on the right is AI generated? So we seem to think that the face on the right is a lot more AI generated, but kind of a 50-50 split. That one is actually the real face. So the face on the right is the real face, the face on the left is AI generated. And again, I think this is kind of an interesting example because it goes to show you that these things are here and they're good, so we have to kind of wake up to the fact that they might have some challenges as well. Now, what are some of the things that we find in our technical ethics chapter? So language models are becoming more capable than ever, but more biased than ever. Who here knows what a large language model is? So large language models are these systems that basically train on massive amounts of data. I'm talking like percentages of the internet, and they're being increasingly invested by a lot of companies because they can so-called learn emergent behaviors. So an emergent behavior is a behavior that a system learns to do without being explicitly programmed to do it. So for example, you have some systems which might have been trained to just understand speech. It turns out they also know how to code as well. So that's obviously very lucrative for a lot of companies, because if you have one of these systems that could learn things that you didn't anticipate, you could maybe now outsource all of your coding to AI instead of actually hiring a team of software engineers. So these are kind of so-called quote-unquote large language models. And it's basically kind of been a trend in the AI space that bigger is better. The larger the model, the more data it is trained on, the better it performs. But one of the things that we also find is that the bigger the models are, the more likely they are to be toxic. So there are certain tests for some of these AI systems called, for instance, toxic continuation. Let's say that I gave you a sentence that was saying, Sarah is a woman, therefore she should work as a blank. Obviously, we would think that certain answers to that question are more biased than others, and you can kind of test to see what AI systems might actually put in that blank. And basically what this chart is showing you is that the larger the model is, the more likely it is to be biased or maybe kind of say something that we deem to be stereotypical versus smaller models. And this is actually quite important because a lot of these companies are pushing to build larger and larger models because those are better for business. Those are probably going to be more lucrative. And it might be great from an economic perspective, but it also might raise a lot of ethical questions and ethical concerns that we might have to slowly start to wrestle with and think about. We also show in the index that kind of the topic of AI ethics is increasingly on the rise everywhere. We have data from a conference called FACT, which is one of the leading conferences on AI ethics, AI explainability, and you'll basically notice that the number of papers submitted to this conference that concern ethics is on the rise year over year. But I would also draw your attention to the teal industry bracket. You'll also notice that industry actors, so researchers that are working in industry, are also contributing more and more papers to these conferences year by year. And that matters, and that's significant because that's suggesting to us that industry actors are probably starting to slowly wake up to the ethical challenges and the ethical realities of some of these technologies. And I would say that that makes sense, right? Because if you're a company that is using AI in a place like Canada or the United States, and it turns out that your system is massively unethical, that could be very bad for your reputation. So I think a lot of companies are trying to figure out to what degree they need to understand some of the ethical challenges and ethical concerns that also surround the use of their technologies. Now, this is also from the report, and I always like sharing this because I think that when people talk about the fact that AI is biased, they kind of nod their heads and like, yeah, obviously AI can be biased. But I think sometimes people struggle to actually understand ways in which AI systems can be biased. So this is a tangible example, and I think it will kind of show you some of the challenges we're dealing with. This is a result from the experiment on CLIP. CLIP is a multimodal language model, one of these kind of new language models that is being increasingly developed. And this model was basically given different photos, and it was tasked to generate captions for those photos that it thought to be the most likely, and it would always generate 2 or 3. So in this case, it was given an image of the American astronaut Eileen Collins, and it generated 2 captions. On the left was a caption, "This is a portrait of an astronaut with the American flag," which is what the portrait is. It gave that caption a similarity score of 28%. And then the other caption that it made is, "This is a photograph of a smiling housewife in an orange jumpsuit with an American flag," which it actually gave a higher similarity score to, 31%. Now, you might be kind of wondering, like, what kind of racist drivel are they feeding these systems? And the way in which this happens is that when you train these large language systems, you need to feed these systems massive amounts of data. Again, I said like percentages of the internet, and it is quite cost prohibitive to actually filter that data. And naturally, if you're giving these models a lot of that data is going to be very stereotypical. There's going to be a lot of conspiracy theories and a lot of just very bad information. So this is now perhaps presenting a challenge to a lot of industry actors that maybe want to be deploying these systems more and have to think more critically about how to filter and how to deal with some of these problems. I won't touch too much on research and development trends because I don't think they're necessarily what this audience is looking for, but we do talk about them a lot in the report. I will note that, again, patent filings have increased more than 30 times since 2015 for AI-related patents. Again, what does this mean? This means that AI is here. More and more people are increasingly interested in using AI technologies, and that really has implications for everybody across the board. Let's talk a little bit about AI policy and governance. What are some trends in the governance world? And I would say if there's one big takeaway that I would have from this section is that legislators and policymakers and lawmakers are also increasingly waking up to the fact that AI is here and we need to kind of start doing something about it. So one of the things that we did in this year's index is we looked at bills that contained the term artificial intelligence that were passed into law into 25 select countries, a lot of major countries. And you'll basically see that there was one such law in 2016, and in 2021 this number grew to 18, which is again suggesting that policymakers care more about this issue and they're waking up more to the fact that this is a relevant issue and a relevant challenge. In terms of what countries passed the most bills in the last year in 2021, you have Spain at the top, the UK, and the United States. And you could also look at data on mentions. So how frequently is AI mentioned in parliamentary proceedings? We also have this data. And again, some of the same countries are at the top here. Canada is kind of in the middle of the pack. But the number of mentions seem to be increasing year over year. And that is again suggesting to us that people in government are waking up about the fact that these technologies are here and that they have some complications and some challenges that we need to think critically about. The last section today is going to be trends in economics with AI. And I'll again note that our report itself, which is over 200 pages, has much more thorough and detailed information. I'm just giving you guys some of the snapshots, and I'd be more than happy to kind of answer any additional questions about this material should you have such questions. One of the things that I think attracts the most interest in our report every single year is kind of how much investment is there in AI. So we basically find in this report that private investment in AI has soared while investment concentration has intensified. So basically, since 2013, the number of billions of US dollars invested in AI companies has just kind of increased steadily, and there was a massive jump from 2022, almost a doubling to 2021. But despite the fact that there is more and more money invested in this space, investment concentration has intensified. You'll basically see that the number of newly funded AI companies in the world kind of peaked in 2018, and since then it has massively decreased, which means that there is more money in the space, but money is going to less and less players. The index stays away from normative analyses, so we don't necessarily comment on what this might mean or why this is the case, but it's an interesting observation. It's a trend that seems to have taken over since 2018 and one that appears to be continuing. We also have a lot of very rich data in the AI index about what particular focus areas attract the most investment when it comes to AI. So in 2021, data management, processing, and cloud was the most invested area, followed by medical and healthcare, and then fintech in third. But you can kind of see how a lot of these other areas stack up, whether it is cybersecurity, HR tech, geospatial tech, and we have this data also disaggregated on the level of countries. So we can see, and if you guys are interested perhaps in seeing this, you can come chat with me after, but we can see how much of this is disaggregated in Canada versus the US, like what are different trends in one country versus the other, what are some of these trends over time. Again, we have data that goes back very, very far, so there's a lot of good opportunities to get a good sense of what the economic situation around AI is. Now, unsurprisingly, America leads the world both in terms of total private AI investment and also in terms of the number of newly funded AI companies. You basically see that in terms of newly funded AI companies, America is massively ahead of everybody else. China is in second. Canada not doing too bad in sixth place over there. Similar in terms of total number of private AI investment. If you actually look at the dollar figures, America number one, China number two, Canada again in sixth place, which is not too bad, but the gap between basically anybody that's not the US and the US is quite massive. One very interesting thing that we also include in the report is a survey from McKinsey that asks leading CEOs and asks leading business executives how concerned they are with AI in their business. And you'll kind of see that a lot of them are concerned about a lot of different things like cybersecurity, things like regulatory compliance, things like explainability, but in the same survey, they asked them how many of these kind of individuals are taking steps to actually mitigate some of these challenges, to deal with some of these challenges, and the numbers tend to be a lot lower, which is suggesting that a lot of business leaders are kind of saying like, yeah, we're worried about it, but not as many are necessarily actually taking tangible steps to resolve some of these problems. We have some data on labor force AI rates, so how penetrative is AI skill set in labor force. India tends to lead in these kinds of categories. Canada doesn't do too badly. There's a large number of Canadian job postings that also require AI skills. And to conclude with some interesting educational information, now it's the case that 1 in 5 CS graduates of PhD programs are specializing in AI, which is just kind of dwarfs the next highest category. And this is, again, suggestive to us of how big of a trend this is and how meaningful research in the space of AI actually is, and how many people are investing time and energy into this. The last trend that I'll conclude with, and I think this kind of speaks to some broader issues that we talk about in the report, is that a lot more PhDs are going to industry over academia. So if you look at the chart on the right, in 2010, there was roughly an equal amount of PhDs that were going to academia and industry. Since then, there's been a massive gap that has opened up. And this, again, means that industry actors are getting a lot more talent. So if you kind of want a summary of some of the big themes that I've talked about today, I think one of the big themes that we find in the report is that in a lot of areas, trends in AI are favoring industry actors, especially large industry actors, over academics. And I think that has a lot of important consequences that we have to kind of be attuned of and kind of meditate on, because naturally industry actors are going to have a different set of incentives and a different set of motivations than academic ones. That's something I'd be happy to chat about off stage. Make sure you guys give our report a read. Again, it's thorough. It has a lot of other information. And check out some of our other offerings. We have a global vibrancy tool that ranks how highly countries do in different AI categories. And we're also working on a lot of other projects like a public opinion tracker, an AI regulations database that might be released in the near future. So thank you guys very much for listening to my presentation. I'll happily take any questions now that you guys might have. Let's go over here first.
Hi, thank you very much for a very interesting presentation. In the economics section, you mentioned McKinsey.
Yeah.
They have an AI value proposition for different industry sectors. Is business impact something you're also tracking?
Yeah, I think that's something that we're looking at for this year's reports. I think that we have included it in previous year's reports, and I think we have data on, for example, like what AI skills different industry leaders are interested in. Like, are they interested more in kind of NLP? Are they interested more in recommendation? And also how that is subdivided by sectors. So I think that is actually in the report. So if you do want to learn more about it, you can give it a read. I think it tends to be a bit more dry, so we tend to keep it off the slide decks, but it's definitely in the report, yeah. Over there.
Thank you very much for the talk. The language model slide was very interesting in that if you're trying to give your algorithm more data, you're looking at 20 or 30 years of internet, right? So let's say this language model was built on writing code. If there is an old style of writing code and a new style of writing code, and the older one is worse, if you train on a larger data set, doesn't mean that the code that the AI generates is the older one or even the buggier one, so more data is worse?
So the short answer is I don't know, because I'm not developing these systems, so I can't necessarily comment on that per se. But I would say that in terms of what's actually kind of in the index, I think that that's kind of the scary and also the very, the very interesting thing about a lot of these language models is they kind of do things people don't expect them to do, which is obviously really cool if if you train it to listen to some speech and all of a sudden it can write poems, it could generate images, it could write code. It's like, damn, this is pretty cool. But theoretically, it could also learn to do some other kind of questionable things that might not necessarily align with human interests. Like there was a paper that was released this week, I think, by Meta. They basically developed an agent to play the human game Diplomacy, and it was an AI agent, and it played this game at a very high level, and in some cases was even able to kind of like lie to humans to achieve results. Like I think that's like the opening line of like so many science fiction horror movies. To kind of answer your question, it's not clear to me necessarily how it works on a technical level, but that is a challenge for researchers, like the issue of filtering, in that you can filter a system to kind of clean some of the data, and it can perhaps perform better on certain sections, but it might make it less likely to then learn other kinds of data.
Thank
I think
you.
we have time for maybe one more question. Can we do over here? Because I think I saw your question first. But I'd be also happy to talk with you guys off stage if there's any further questions.
Right. Thank you. Yeah, I see the index report has touched a lot of areas and industries on economies, and especially on the cost wise. Like training model has a dollar assigned to it, but does the index also cover the energy cost? Like, what's the impact on climate and the sustainability of AI?
Yeah, really happy you mentioned that. We're actually working on that for next year's report because that's obviously a big consideration. You look at like some of these large language models, the energy input is kind of huge. So that's something important to track and something that we're increasingly interested in paying attention to. All right, thank you very much, guys.